guys, today we are going to talk about a couple of things. We are going to talk about the rational zeros theorem, and then we are going to talk about Descartes' rule. I'm just reading up here in the notes. The rational zeros theorem is a technique used to identify potential rational zeros or solutions or roots. They're potential. It doesn't necessarily mean that they all have to be zeros. This says for a polynomial function in standard form, the potential rational zeros of the function are plus or minus p over q, where p are the factors of the constant and q are the factors of the leading coefficient. Now, this probably doesn't make sense right now, but we're going to do a couple examples, so it should make sense. So if we look at function a, our q are going to be the factors of 2. Our p are going to be the factors of 6. So we're going to do plus or minus p over q. And so when I do this, I'm going to do the plus or minus outside. You can absolutely do that. So factors of 6, this goes in our numerator. So we would have 1, 2, 3, and 6. Factors of 2 would be 1 and 2. Okay, so on top, we could have factors 1 through 6. On the bottom, we could have factors 1 and 2. So I have to look at all of the possible rational zeros. So that final answer is going to be plus or minus. And again, I'm going to put it outside because I could have plus or minus either one of these. So I have everything on top. 1, 2, 3, and 6. Plus, I also have to look at, I would have 1 over 1, which is 1. I would have 2 over 1, which is 2. Then let's get rid of those. I would have 3 over 1. Okay, that's going to be 3. 6 over 1 is also going to be 6. But then I could have 1 over 2. So I'm going to look at 1/2. And the only other one that would be different would be 3 over 2. So my possible rational zeros would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2. We're not going to do every single one of these problems, but let's look at B. B, if I look at the same thing, I have Q and I have P. Now Q is 1 and P is 5. This is kind of a nice one because the only factors of 5 are 1 and 5. So I would have plus or minus P over Q, which is going to be plus or minus factors of 5 are 1 and 5. Factors of 1 are just 1. So my final answer is going to be plus or minus, and basically it's going to be 1 and 5. So plus or minus 1 and plus or minus 5. Okay. If we look at C, now C, we have actually a lot more. So we have, here we have P and we have Q. We would have plus or minus. I'm going to look at, we have factors of 20. 1, 2, 4, 5, 10, and 20. Factors of 6 would be 1, 2, 3, and 6. Now, I would like you to pause the video and see if you could write out all of the possible factors. Okay, hopefully you did that. Possible factors would be all of what's on top. Whoops, 4, 5, 10, and 20. Then we would also have, I'm going to look with everything with a 1 in the numerator. 1/2, 1/3, 1/6. I'm going to do the same thing with 2. 2 over 1 is 2. We've already used that. 2 over 2 is 1. We've done that. We would have 2/3. We would have 2/6, which is 1/3. We used that already. I would continue through the rest of the problems, the numbers on top. And so I would have 4/3, 5/2, 5/3, 5/6, 20/3, and 10/3. And keep in mind that everything is plus or minus. Wow, there are a lot of different options for rational functions. So these could just help you out when you're trying to find zeros of the functions. These are possible ones. You can list them out and it can help you at a starting point. Now, the next thing we have is called Descartes' rule of signs. This is a technique used to determine the possible number of positive real zeros and possible number of negative real zeros. You can go ahead, read this information, these steps, if you get stuck, but I'm going to go ahead and do some examples. So what I would do in order to find my possible real zeros, so I'm just going to, I'm just going to put a P there. I look at the sign changes. And so when I'm talking about a sign change, I'm going from a negative to a positive. So this is one sign change. Then you could see from +4 to +3, that's not a sign change, so I'm not going to count that. But then I would go from a +3 to a -2. So that's a sign change. And then the last one is a negative to a negative. That's not considered a sign change. So I have 2 possible positive real zeros. And what I do is I always have to, it says for number 4, you count down by 2. You're not going to go into a negative number. So you could have 2 positive real zeros, or you would do 2 minus 2, which is 0. So, and I'm going to change this. You could have 2 or 0 positive. Okay. Now negative, what I do for my negative is I go ahead and this says here, well, first of all, we always have to make sure that we line up the terms in decreasing order. Then we change the signs of the odd powers of x. So 7 is considered an odd power. So this is going to be a positive. This is even, so I keep it the same, positive. This is even, I keep it the same, positive. Oh, this would be considered an odd power. So this is going to also, I'm going to change it from a negative to a positive. And then here, this is just negative. So I need to look now at the sign changes. Well, I only have one sign change. So that means for the negative real zeros, I only have one possible -0. Okay, let's go ahead and let's look at B. So I'm going to do the positive first, so I don't have to change any signs for that. So here I'm going from a positive to a negative. That's one sign change. Okay, again, a negative to a positive, that's a second sign change. Positive to positive, that's not going to work out, but I go from a positive to a negative. That's a sign change. And so that means I have 3 possible positive real zeros. So I would have 3, and then I also do 3 minus 2. I could have 3 or 1 positive numbers. Now, if I look at my negative, remember, any odd one I'm going to change. So this is still positive. This is still negative. Oh, here we go. This is odd. So this is going to be negative, positive. Here we go. This is odd again. So this is positive and negative. So I want to look at how many sign changes I have. So I have 1, I have 2, and I have 3. So for the negative real zeros, I could have 3 or I could have 1. Okay, Now, the next thing we're going to do is this says the number of real zeros theorem. We are going to talk about, it says if a polynomial of a degree n, then f of x has at most n distinct zeros. This means that the number of zeros should add up to the highest degree of the polynomial. So if I look at example A, my highest degree is 3. So this means I'm going to have 3 zeros. Now, I could have imaginary zeros too. And so let's go ahead, let's use Descartes' rule. And so we know that we have a 3 total of zeros for Descartes' rule. If I look at my positive, I'm going to go ahead and I'm going to erase this right here. Where I have a sign change, I basically have one sign change here. So it's going to be 1. Now for my negative sign change, I'm going to go ahead and change my odd degree. So this is going to be positive, negative, negative, positive. I have 1 sign change. I have 2 sign changes. So for my negative real zeros, I could have 2, or I can also subtract 2 from that. 2 minus 2 is 0, so I could have 0. Now, we know that there are a total of 3 because of this highest degree. And what I like to do is I kind of like to do a chart. I have a positive zeros, negative zeros, and imaginary. So let's say I have 1 positive. I could have 2 negative. 1 plus 2 is 3, so that means I would have 0 imaginary. So this is 3 total. I could also have 1 positive, or I could have 0 negative. That means I would also have to have 2 imaginary, because that adds up to 3 total. So this is a little chart that helps this work. I will tell you that imaginaries, from what we learned before, it has to be an even number, 0, 2, 4, 6, or so forth. Okay, if we look at B now, we have a total of 5 zeros. Okay, so now I'm going to erase that. If I want to look at how many positive I have, I look at my sign changes. Here's 1, here's 2. So I could have 2 or 0. My negative, I'm going to go ahead, I'm going to change this to positive. This stays positive. This is positive. And this is negative. So I only have 1 sign change. So I would have 1. Now if I do my chart, oops, I don't know why I made my T like that. Okay, I could have 2 positives with 1 negative. Remember, I need a total of 5, so that's 3, so that would be 2 imaginary. Or I could have 0 positives, 1 negative, and that would give me 4 imaginary, because again, we have to add up to 5. Okay, if I'm going too fast, just stop the video, rewind it, and look at the example again. We'll also be able to talk about this in class tomorrow. Okay, for example 4, it says find the possible number of positive, negative, and complex zeros. Then find all of the possible rational zeros. So if I look at this, okay, first of all, I should have a total of 4 zeros. For positive, I look at my sign changes. I have 1 sign change. I have 2. So I'm either going to have 2 or 0. For negatives, I'm going to go ahead and change my odd ones. So this is still positive. This becomes negative. Negative, positive, positive. one sign change, two sign changes. So this could be 2 or 0. So now when I do my chart, I have positive, negative, imaginary. Now remember, I need to add up to 4. So I could have here, I could have 2 positives with 2 negatives, and then that would give me 0 imaginaries because I have to add up to 4. I could also have 2 positives with 0 negatives, and then that would give me 2 imaginaries. Or now I can work my 0. I could have 0 positives with 2 negatives, 2 imaginaries. Or my last one is I could have 0 positives, 0 negatives with 4 imaginaries. Okay. I know I'm going fast, but again, stop the video if you need to stop the video. Okay, the very last example says find all of the roots and then factor. There's several different ways that you could do this, but if you think about this, if we think about using Descartes' rule, we would have plus or minus 1, 2, because we have factors of 2, over 1, 2, 3, or 6, factors of 6. And remember, we are going to have 4 zeros. And so you have to think about, we could have plus or minus 1, 2. We could have 1/2, 1/3, 1/6. We could also have 2/3 or 1/3, which we already accounted for. I always try to use, before I use a fraction, I always try to use either plus or minus 1 or 2. Now, when I go ahead and do that, I'm just going to start with positive 1. And I use synthetic division. So I have 6, 7, negative 12, negative 3, and 2. I'm going to bring this all down. You guys should be doing this as we go along too. So this is negative 2. Oh, look at this. This is perfect. This is going to be 0. So we know that 1 is a 0. Now, I tested some of them. I found out that negative 1 and 2 did not work, so I'm going to use negative 2. And that would be testing out. For time, I'm not going to go through testing. So here I would have 6. I'm just kind of going through negative pretty quickly. So this becomes 2. Look at that. That's 0. So what happens now is I started with x to the 4th. This would be x cubed. Now this is x squared. So I have 6x squared plus x minus 1 equals 0. I will try to factor this. This factors out. So I get 2x plus 1, 3x minus 1. So here I have a 0 of x equals negative 1/2 and x equals 1/3. So I have 4 zeros, so my zeros are going to be, I cannot forget what I originally started out with, 1, negative 2, negative 1/2, and 1/3. Okay, I know I went through this really quickly, so please, if you have questions, go back and look at the video. You can ask questions tomorrow in class too. All right, guys, have a great night.